My name's Alan Wilson. I'm the Engineering Director for MK Test. We were 30 years old last week, so the company's been in this area now for 30 years, founded by two engineers, but has grown steadily over the years. About 7 years ago, we were bought by a private equity firm who've been investing in our future. So we're now up to 44 people, and in this lovely purpose-built building we moved into about 3 years ago. Predominantly making test equipment for manufacturers, and all the way up and down the supply chain. So we work with Boeing and Airbus, all the way down their supply chain to the people that make the smallest harnesses. And it's testing electrical cables. When people make a cable, they have to check they've connected the right pins together. They have to check there's nothing shorting together, and then also check they haven't damaged them. So we apply a high voltage to see if it leaks anywhere, in effect. Very little of our equipment actually ends up on the final product. It's used on the production lines to test the product as the Airbuses of this world or the Alstroms are making trains, etc. So as they install all the harnessing, cabling into the vehicle, they'll use our equipment to check they put it in the right place, they've not damaged it, and then when they put their expensive computers in, it all works together correctly. So it's very much productivity aid, and the whole point of the automated test is that we can test tens of thousands of connections automatically, quite quickly, rather than a technician walking around with a multimeter, which is the old-fashioned way of doing it. When you're starting to get hundreds of thousands of wires in these structures, it has to be automated. All our customers are just very keen on making their products faster and more efficiently. So the likes of Airbus and Boeing are currently trying to raise their throughput to 50 or 60 aircraft per month, which is a lot of aircraft to be making. And so every minute they can save in production is a cost saving to them, and they can increase that throughput. We had one example of a train manufacturer who did the study and reckoned they'd reduce their test time from about 16 hours to, I think it was 6 minutes, just by automating the equipment. And you can see that it saves manpower, it saves time. So anything we can do to make things go faster, our customers are interested in. Well, I guess we're very fortunate here. We've got the whole range from design engineers who literally start with a blank sheet of paper trying to solve a customer's problem, through the software guys writing software to support it, the people that lay out the printed circuit boards, down to the technicians that then are building these parts, through to the test engineers that make, because everything goes out of this factory thoroughly tested. But we also have service guys out in the field then who'll go and do the installation, and they'll look after our equipment, because most of our equipment is serviced on an annual basis. So we've got a team of service engineers going out doing that. And obviously there's a lot of support functions like purchasing and procurement, quality people, obviously finance people, keeping us in order, making sure we don't overspend. I mean, we always like to consider we're a large family in many ways, so the people's flexibility and fit with the team is also important. But we also want people that want to work here. Our interview is quite thorough, and we obviously have the technical interview, where we make sure they've got the technical skills, but a lot of it is about how well they fit in with the rest of the team and how well they want to work here. I mean, it's a very pleasant environment, friendly environment to work in, but there's only 44 of us, so we all know each other and we have to get on with each other. So, and flexibility is probably one of the key features, because we are small, we have to be flexible. This is a typical Automeg system, which consists of a computer and control system at the top, but then banks of relay cards. So each of the connections on there is a test point. And to test an aircraft cable, for instance, you'd attach a test point to each end of the cable, and then you use low voltage to test it's connected to the right places, and then high voltage to see if the cable's been damaged. You can associate this a high voltage with water. If you put high pressure in a hose, you'll find the leaks. Yeah. If you put high voltage in a cable, you'll find the leaks. And that's what we're doing. This is destined for a train manufacturer, Alstom. And this is the main control unit, but it has a number of satellites, because they're trying to test a 30-metre long carriage. So there'll be this lot at one end, the other cabinets at the other end, all controlled by the same computer, and it's testing cables from one end to the other.
It's great to have you guys here. My name is Yassine Rostom, and I'm an electronics design engineer. As I just mentioned, I'm an electronics design engineer in the NPD team at MK. Our team designs and develops new generation test equipment. Basically, we don't look at what our equipment are going to be now. We look at the future. What will our customer want in 3 years or 5 years or maybe sometime 10 years? And we start putting requirements and doing prototype boards and seeing how can we reach our goal. The project I'm working on now is redesigning MK legacy product, which is this beautiful kit, and updating it to use the SMT or SMD new technology. So for instance, this is one of our old legacy product boards. As you can see here, these chips are through-hole technology, which are a bit larger. This is a MOSFET, and this is a relay. These chips are larger because all of this technology is around 80s, 90s. By that time, that was great. But actually, given that we're in a really dynamic industry, things move really fast. So now, basically, this chip can be replaced by this small solid-state switch. This explains why your cell phone is going smaller, everything is going more portable, because the chips or the integrated circuits that go inside your product is getting smaller, and that's what's making things more efficient. Actually, one of the other things the industry is looking at now is making these small chips low energy, so it's more efficient, because think about it. Everything is now portable. For instance, AirPods, whatever. It's normal that things now is portable, so low energy, low power chips is becoming the new thing now in our industry compared to these old chips which consume more power, more current. So yeah, as I mentioned, I'm working in the NPD team, and my current project is designing the same product basically, or redesigning the same product using the SMD or SMT, surface mount technology, in order to make our products more efficient. And one of the other problems our legacy product is facing now is obsolescence. A lot of these chips are going out of the market because for their manufacturers, it's not cost effective anymore to design these chips which have higher costs compared to these small chips which have higher demand. So here, lower demand, high prices, here, lower costs and higher demand. So we have to stay up to date with the market. Actually, one of the other things about our industry, which is electronics or technology in general, is that things are really dynamic. Things change quickly. And as the engineering director, Alan, have just mentioned, that we are looking at AI, computer vision, machine learning, and because our customers are starting to think about that, because they're seeing that all around them with your cell phone, Siri, Google. So our next step as an NPD team is to think how can we implement that in our industry. If you're gonna ask me about what's my normal day at MK, as an NPD team, there's nothing cool like a traditional day. We don't have a routine because you're always designing and developing new products. So every day is a new learning day. You're gonna come across a new design challenge, a new bug you haven't faced. So this is the interesting about our job, that there's no routine to it at all. Like, I can't say what I'm gonna be doing in 2 weeks. You make a project plan, which it never goes right, because this is design development. It's more about trial and error. Okay, you make assumptions, and the more experience you build, the better you get at it, and the more confident you are. So speaking of, for instance, this product, the relay board Alan has showed you outside in the 6U rack. This is the new generation of it. We're trying here to make our product smarter. So this chip is only, this board is only using 85 milliamps, which is, in our world, that's efficient, that's good. And as I showed you, this is what's happening on the board. These are the comms. Like, this is how chips communicate, how they speak to each other. This is interesting because this have speed. So if I show you here measure, this is gonna tell you the different voltages and the frequency. In this world, it's binary. It's either 1 or 0. Yeah. Okay, so a 3.3 volt is gonna be a 1. Yeah. A 0 volt or ground is gonna be 0. So as you can see here, it is changing between zeros and ones. So based on if it's either a 0 or 1, I can figure out the information that this chip wanna tell me. Yeah. And based on it, I take an action. Yeah. That's how it works. But actually, the beauty of us being a small team, that as an electronics engineer, you do all sorts. Like, for instance, today I was doing pretty much a mechanical design, but this is for the good of this system. So this is explosion drawing to show you how to assemble one of the systems. This is a power supply. And on the side, I was coding. There's a lot of hype now around technology, software engineers, but I would advise younger generations to invest their time in order to explore their interests, because it's not about just programming. There's 1,000 programming language, and there's 1,000 applications for different programming languages. It's more about what you are gonna enjoy doing every day, what's gonna excite you, and when you figure out that, it's so easy to learn something. But actually, I think the hard question here is, what do you want to learn? And because I was lucky that my grandfather been always directing me, because he is also an electrical engineer and he had knowledge of the technology. So I always had a reference. So try to find a mentor, a reference, somebody who you can trust and you can go to. And then when you figure out what you really enjoy, it's so easy to learn. You can go to university, you can do an apprenticeship, you can learn from online courses. It's not how you're gonna learn, it's what do you wanna learn. I think this is really the question. And my advice for younger generation, just spend your time and figure it out, man.